Hello and welcome to Health Matters on Channels Television. Thanks for staying with us. I am Mary Alale Yusuf. Regenerative medicine or stem cell therapy is a branch of translational research in tissue engineering and molecular biology where stem cells may be used to replace, repair, reprogram or renew deceased cells. This means first that there is hope of restoring structure and function to tissues. It also seeks solutions for permanently damaged organs. This way, previously incurable conditions could be cured. My guest today is Dr. David Ikudaisi. Dr. Ikudaisi is a specialist in regenerative medicine and the medical director of Glory Wellness and Regenerative Center with branches in Lagos and Abuja. You're welcome to the show, sir.
Thank you, Mary.
Can you explain to us in simple terms what a stem cell is?
Yes. Stem cell is a cell that has the ability to, replicate itself or differentiate into different tissues or cells in the body.
Okay, so these stem cells are the things, let me put it that way, that are used for regenerative medicine. Am I right?
You are correct.
Where do you harvest them from?
There are a couple of sources of stem cells, which kind of lead to the types of stem cells that do exist. The one that people normally think of when they hear the word stem cells is the embryonic stem cells. And this is kind of controversial, and for, either because of religious reasons or ethical reasons. And that's because the stem cells are being harvested from blastocysts, from potential future human beings.
Okay.
That's one part. Another source could be maybe from an adult skin. We can take stem cells, take it to the lab, reprogram it. Maybe the researchers can grow nose, ears, and different organs. The embryonic and these other stem cells done in the lab, which is called iPSC, induced pluripotent stem cells, both of them have unlimited growth, okay, which means there's also possibility of developing cancer. Now, the third one, which is the interesting one, is adult stem cell therapy. The word adult comes into place because it's from fully formed human. So, and it can be from umbilical cord, because
so if you take it from the umbilical cord, it's still an adult stem cell?
Yes, it comes under adult stem cell. The adult is not about age. It's about fully formed human being. So umbilical cord stem cells, which is kind of more complex to obtain, but it's supposed to be the best. And the other
and it's ethical.
And it's ethical. Because right now in US, every baby born, sample of the blood is taken, umbilical cord is being stored in the stem cell bank for 25 years and so on, just in case the baby develops a problem in future, and they can always go back. You and I can't get our umbilical cords stem cell anymore. Okay. So now that being said, another source for adult stem cell therapy will be the bone marrow or fat from the abdomen. And bone marrow stem cell therapy has been in place as early as 1948, 1968, and when the first bone marrow transplant was done in US. So it's nothing new. But the stem cell from fat is kind of newer.
Is it superior, the one from fat?
Yes. There are studies on the US Library of Medicine, NIH, that shows that adipose, that is fat, adipose-derived stem cells, they differentiate better for neurological disorders. Studies have also shown that adipose-derived stem cells, when compared volume to volume with bone marrow, there are about 500 times more stem cells in adipose-derived stem cells than bone marrow.
Okay, so no need to use
invasive.
No need to use the bone marrow anymore, since you can get the fat. Isn't that right?
That is correct, and that is gaining more popularity because it's more friendly, less invasive.
Okay, so let's bring this home. What conditions do you use this procedure for? What kind of conditions can it be applied to?
As there's just so many. The list is long. I try to make it simpler that any condition except things like HIV and cancer is what is currently not being used for.
So in other words, non-communicable conditions can be handled mostly with this?
That is correct. But the list is just broad. Diabetics, arthritis, fibromyalgia, cerebral palsy, multiple sclerosis, autoimmune disease, lupus, and I think I mentioned arthritis. It's
lupus.
Yes.
That's great.
And the list is just endless.
Okay. You mentioned something earlier where you said something, growing a nose, growing an ear.
Yes.
Do you do that sort of thing? Like put it in a petri dish and it begins to grow stuff?
I don't do that. Okay. Or the centers where I work, we don't do that there. But it's been done in research lab, in European countries and in US. Remember, I said there are 3 types of stem cell: embryonic, which is controversial. Then the induced pluripotent stem cells, that's when the cells are grown in the lab, which is what you're asking about.
Okay, and those are the ones you said have a potential. Those are the ones that have a potential to lead to cancer, right?
That is correct.
But adult stem cells do not have a potential to lead to cancer.
They do not, and the reason is this. Okay, you see, the embryonic and induced pluripotent stem cells, they have unlimited growth. They just keep multiplying, Now, the adult stem cells have limited growth, limited replication. That negativity is actually a positivity in the clinical application. That is why we're able to use it, because we don't have to worry about your treatment turning into cancer.
So it stops at a certain point.
That is correct. And by that time, the repair or the regeneration will have been done.
Okay. Now, I'm trying to picture this and make the viewers picture how a bit of fat you got from somebody's body can cure his diabetes.
Okay.
How does it happen?